The National Electrical Code, often abbreviated as NEC, mandates a grounded conductor, also known as a neutral conductor, at all 120-volt receptacles or outlets in dwelling units. This requirement extends to outlets designated for switch locations, and it is outlined in NEC sections 210.70 and 404.2. However, the NEC does provide some exceptions. Specifically, it allows for the use of an equipment grounding conductor, referred to as EGC, as a grounded conductor in certain limited situations. This exception typically applies where the outlet is fed by a non-metallic sheathed cable and the equipment grounding conductor is continuous and bonded to the grounded conductor at the origin of the circuit. This provision is detailed in NEC section 250.142c. It's important to understand that this is an exception and not the standard practice. There have been ongoing efforts within the NEC code-making process to implement a broader requirement for grounded conductors at all outlets, including switch locations. For example, in the 2020 NEC cycle, a proposal, specifically Proposal 13.6, was submitted to amend NEC Section 404.2 to mandate a grounded conductor for switch locations. While this proposal was initially considered, it was later reconsidered and ultimately withdrawn in the 2023 NEC cycle. This highlights the ongoing debate and evolution of electrical codes. Given these requirements and considerations, here are several suggestions to ensure compliance and promote safety. Firstly, ensure that all outlets, including those intended for switch locations, are properly equipped with the grounded conductor in accordance with NEC sections 210.70 and 404.2. This is the fundamental requirement and should be the primary focus of any electrical installation. Secondly, avoid substituting the equipment grounding conductor for the grounded conductor at switch locations. This practice can introduce significant safety hazards and may invalidate any applicable warranties on the electrical devices or systems. It is crucial to maintain the integrity of both the grounding and neutral systems. Thirdly, consult with the local authority having jurisdiction, often abbreviated as AHJ, which is essentially the local electrical inspector, for specific requirements in your area. It is important to note that some jurisdictions may have adopted stricter code requirements than the minimum standards set by the NEC. Adhering to local regulations is essential for legal compliance and safety. Finally, consider actively supporting code changes that advocate for a grounded conductor at all outlets, including switch locations, by contacting the NEC code-making panel to express your support. This can help to influence future code revisions and promote safer electrical practices. To further clarify, let's delve deeper into the function and importance of grounded conductors, equipment grounding conductors, and the potential hazards of misusing them. The grounded conductor, or neutral, provides a return path for current in a normal electrical circuit. It is intentionally connected to ground at the service entrance, which is typically at the main electrical panel. This connection to ground ensures that the neutral conductor is at or near 0 volts potential relative to ground. This is essential for proper circuit operation and safety. The equipment grounding conductor, on the other hand, is designed to provide a low impedance path back to the source in the event of a fault, such as a short circuit to the metal enclosure of an appliance or electrical equipment. When a fault occurs, the equipment grounding conductor carries a large current back to the source, causing the circuit breaker or fuse to trip, thereby quickly disconnecting the power and preventing electrical shock hazards. The equipment grounding conductor is connected to all metal enclosures of electrical equipment and appliances, providing a path for fault current to flow back to the source. Now, let's examine the dangers of using the equipment grounding conductor as a substitute for the grounded conductor at switch locations. This practice creates a situation where the equipment grounding conductor is carrying normal circuit current, which is not its intended purpose. This can lead to several problems. Firstly, it can cause the equipment grounding conductor to become energized, which creates a shock hazard if someone comes into contact with the metal enclosure of an appliance or electrical equipment. Secondly, it can interfere with the proper operation of ground fault circuit interrupters, often abbreviated as GFCIs, which are designed to protect against electrical shock hazards. GFCIs work by detecting small imbalances in the current flowing through the hot and neutral conductors. If the equipment grounding conductor is carrying normal circuit current, it can mask these imbalances, preventing the GFCI from tripping and providing protection. Thirdly, it can increase the risk of electrical fires. When the equipment grounding conductor is carrying normal circuit current, it can overheat, especially if the connections are loose or corroded. This overheating can ignite nearby combustible materials, leading to a fire. In addition to these safety hazards, using the equipment grounding conductor as a substitute for the grounded conductor may also violate the terms of warranties on electrical devices and systems. Many manufacturers require that their products be installed in accordance with the NEC and other applicable codes. Using the equipment grounding conductor as a substitute for the grounded conductor is a clear violation of these codes and may void the warranty. It's also important to consider the specific requirements of aftermarket logic and automation devices, which are becoming increasingly popular in residential and commercial markets. Many of these devices require a grounded conductor for their proper operation. These devices often use the grounded conductor as a reference point for their internal circuitry, and if the grounded conductor is not present, the device may not function correctly or may even be damaged. In conclusion, the NEC mandates the grounded conductor at all 120-volt receptacles, including switch locations, in dwelling units. While there are limited exceptions, it is generally not permissible to substitute the equipment grounding conductor for the grounded conductor. Doing so creates significant safety hazards and may violate applicable codes and warranties. It is essential to consult with the local authority having jurisdiction and to support code changes that promote safer electrical practices. To re-emphasize some key points, consider these additional factors. Firstly, the size of the grounded conductor is crucial. NEC Section 250.24 code dictates that the size of the grounded conductor must be sufficient to carry the neutral current. In many cases, this means the grounded conductor must be the same size as the ungrounded conductors. Secondly, the grounding electrode system must be properly installed and maintained. This system provides a low impedance path to ground, which is essential for safety. NEC Article 250 provides detailed requirements for grounding electrode systems. Thirdly, ground fault circuit interrupters, GFCIs, and arc fault circuit interrupters, FCIs, play a critical role in electrical safety. GFCIs protect against electrical shock hazards by detecting small imbalances in current, while FCIs protect against electrical fires by detecting arc faults. These devices should be installed in accordance with NEC requirements. Furthermore, the NEC is updated every 3 years, so it is important to stay current with the latest requirements. The NEC is a complex document, and it is recommended to consult with a qualified electrician or electrical engineer if you have any questions or concerns. In addition, proper labeling of conductors is essential for safety and troubleshooting. The grounded conductor should be identified by a white or grey color, while the equipment grounding conductor should be identified by a green or bare color. This helps to prevent confusion and ensures that the correct conductors are used for their intended purposes. It's also important to consider the impact of voltage drop on electrical systems. Voltage drop occurs when the voltage at the load is less than the voltage at the source. Excessive voltage drop can cause appliances and equipment to malfunction or overheat. NEC Section 210.19 AM provides guidelines for minimizing voltage drop. When working with electrical systems, always follow lockout/tagout procedures to ensure that the power is disconnected before performing any work. This helps to prevent accidental electrical shock. Also, use appropriate personal protective equipment, PPE, such as insulated gloves and safety glasses, to protect yourself from electrical hazards. Regular inspections and maintenance of electrical systems are essential for preventing problems and ensuring safety. This includes checking for loose connections, damaged wiring, and other potential hazards. Finally, remember that electrical work should only be performed by qualified individuals who have the necessary training and experience. Working with electricity can be dangerous, and it is important to take the proper precautions to protect yourself and others. To reiterate, the grounded conductor is a critical component of electrical systems, providing a return path for current and ensuring that the neutral is at or near 0 volts potential relative to ground. The equipment grounding conductor, on the other hand, is designed to provide a low impedance path back to the source in the event of a fault. It is generally not permissible to substitute the equipment grounding conductor for the grounded conductor, as this creates significant safety hazards. Always follow NEC requirements, consult with the local authority having jurisdiction, and support code changes that promote safer electrical practices. By understanding the function and importance of grounded conductors and equipment grounding conductors, and by following these guidelines, you can help to ensure the safety and reliability of electrical systems. Furthermore, consider the implications of using surge protective devices, SPDs. SPD are designed to protect electrical equipment from voltage surges, which can be caused by lightning strikes or other electrical disturbances. SPD are typically installed at the service entrance or at individual branch circuits. When installing SPD, it is important to follow the manufacturer's instructions and to ensure that the SPD is properly grounded. A properly grounded SPD can effectively divert surge current to ground, protecting sensitive electronic equipment from damage. It is also crucial to address harmonic currents in electrical systems. Harmonic currents are currents that are multiples of the fundamental frequency, which is typically 60 Hz in the United States. Harmonic currents can be generated by nonlinear loads such as electronic ballasts, variable frequency drives, and computers. Excessive harmonic currents can cause overheating of transformers and conductors, as well as interference with sensitive electronic equipment. To mitigate harmonic currents, it is important to use harmonic filters or other mitigation techniques. NEC Section 220.61 provides requirements for calculating neutral conductor load, which takes into account the effects of harmonic currents. In addition to these technical considerations, it is important to address the ethical implications of electrical work. Electrical contractors have a responsibility to provide safe and reliable electrical systems. This includes following all applicable codes and standards, using high-quality materials, and performing work in a professional manner. It is also important to be transparent with customers about the costs and benefits of different electrical solutions. Building a reputation for honesty and integrity is essential for long-term success in the electrical industry. Also, remember the importance of energy efficiency in electrical design. Designing energy-efficient electrical systems can save money on utility bills and reduce the environmental impact of buildings. This includes using energy-efficient lighting, appliances, and equipment, as well as optimizing the design of electrical distribution systems. NEC Section 220 provides requirements for calculating electrical loads, which can help to optimize energy efficiency. Training and education are also critical for electrical professionals. The electrical industry is constantly evolving, and it is important to stay current with the latest technologies and techniques. This includes attending continuing education courses, reading industry publications, and participating in professional organizations. Investing in training and education can improve your skills and knowledge and can help you to advance your career. When performing electrical work, it is important to document your work properly. This includes creating accurate wiring diagrams, labeling circuits clearly, and keeping records of all inspections and tests. Proper documentation can help to troubleshoot problems in the future and can also be used to demonstrate compliance with codes and standards. Also, remember to consider the specific needs of different types of buildings. The electrical requirements for a residential building are different from those for a commercial building or an industrial building. It is important to understand the specific requirements of each type of building and to design electrical systems accordingly. This may involve consulting with architects, engineers, and other professionals to ensure that the electrical system meets the needs of the building and its occupants. When working with electrical equipment, it is important to follow the manufacturer's instructions carefully. This includes proper installation, operation, and maintenance procedures. Failure to follow the manufacturer's instructions can lead to equipment failure, electrical shock, or other hazards. Furthermore, regular testing of electrical systems is important for ensuring safety and reliability. This includes testing ground fault circuit interrupters, arc fault circuit interrupters, and other safety devices. Testing should be performed by qualified individuals using appropriate test equipment. In addition to these considerations, it is important to stay informed about changes in codes and standards. The NEC is updated every 3 years, and there are also other codes and standards that may apply to electrical work. Staying informed about these changes can help you to ensure that your work is compliant and up to date. Consider the use of smart home technology and its implications for electrical systems. Smart home devices, such as smart thermostats, smart lighting, and smart appliances, are becoming increasingly popular. These devices can be controlled remotely and can provide energy savings and other benefits. However, they also require careful planning and installation to ensure that they are compatible with the existing electrical system and that they do not overload circuits. Always remember to prioritize safety when working with electrical systems. Electrical work can be dangerous, but by following the proper procedures and taking the necessary precautions, you can minimize the risk of accidents and injuries.